Swayam Prabha. Digital India. Educated India.
Hello everyone, we are continuing with the environmental regulations and the regulatory instruments, and we in the last lecture we discussed about the market based instrument, that is the pollution tax or pollution fee. So, today we will be continuing the same one and we will be discussing what is the Pigouvian fee that we discussed, and now we will be discussing how this Pigouvian fee is a kind of special emission fee or special pollution fee, right. It is not a pollution fee as such, but it is a special category of pollution fee or emission fee that we will be discussing. And then we will be discussing the Pigouvian fee if a single polluting farm is there. So, how the Pigouvian fee is decided, and then we will be discussing in the presence of multiple polluters how this Pigouvian fee is going to be determined, right. So, now let us talk about that how Pigouvian fee is treated as a special pollution fee, not a pollution fee. So, as you understand, and we have already discussed in Pigouvian fee or Pigouvian tax lecture, that it is a kind of emission fee, and this emission fee is determined at the marginal damage of the pollution itself. And moreover, this emission fee is exactly equal to the aggregate marginal damage, and when it is evaluated at the efficient level of pollutions, right. So, that means here we want to say that Pigouvian fee is determined as per the aggregate marginal damage, and this aggregate marginal damage is estimated based on the efficient level of pollution. So, this efficient level of pollution is also the optimal level of pollution. So, you can remember the optimal externality or how we are determining the optimal or efficient externalities. So, after understanding this just Pigouvian fee, the definition that we discussed earlier. So, now we will be discussing how this Pigouvian fee is going to be determined, going to be set if under the case when a particular farm is a polluter. So, here we are taking into account as if only one single farm is there who is polluting. Okay. So, from the previous class we already understood that this marginal saving function, right, from pollution is equivalent to the negative of the marginal cost function of the pollutions, right. And again we know that the total damage cost, given this total damage cost from the pollutions, we can find this total cost. So, what is the total cost? Total cost is the composition of these two terms. The first one is the abatement cost, that how the farm is going to spend and reduce the level of pollution, and the second one is if the farm is not at all going to reduce it, what is the damage cost it is taken into account, right. So, we can say this total cost is equivalent to the abatement cost, that is a function of the pollution level, and also the damage cost, that is also a function of pollution level. Okay. So, given these, now we will be finding that how this Pigouvian fee is determined when the pollution when the polluter is a single entity, right. So, we can graphically explain that first. So, we can take in the horizontal axis we are explaining the pollution itself, pollution, and in the vertical axis we are measuring the price and cost. Okay. And we know the marginal saving function what is the shape of this marginal saving function? It is negative, okay, and this marginal saving function is equivalent to what? The minus of marginal cost. We have already learned that what is the marginal saving function and what are the features of marginal saving function as well as the features of the marginal cost function, right. Now, we are saying that the single polluter is there, right, and as a result let us say that because of this pollution activity it is impacting and damaging let us say two persons. So, that means there are two victims of the pollution, right. So, we are saying that let us say this is the marginal damage function of the first victim and this is the marginal damage function of the second victim. Okay. So, now we are saying that this MD1 is the marginal damage to the first victim and this MD2 that we have just drawn is the marginal damage cost to the second victim. And as you understand, this damage is obviously not a private good or private bad, right. So, this damage is obviously not a good, it is a bad first thing, and second one is it is not a private bad, it is a social bad or public bad. So, because this pollution damage is the nature, so far the nature and characteristics of goods and bads are concerned, it is not in the category of private good, rather it is a private, it is a social good. So, take into account this the very nature that it is social or public we can say. So, the aggregate damage that is we are finding, right, from the action of the polluter, it can be obtained by the vertical summation of the individual damage cost. So, if you have to find out what is the aggregate damage function that is borne by the first victim and the second victim. So, you have to actually add up and this would be the vertical summation, not the horizontal summation. So, remember that in case of social good or social bad, if you have to find out the aggregate of anything, any social good or social bad, so it should be added off vertically. So, now as you understand this damage, pollution damage is a social bad. So, therefore, the marginal damage function for the society or the total marginal damage function can be summed up, this is vertically. So, this MD1 and MD2 are vertically summed up in order to find out the aggregate damage function, right. Let us say this is the aggregate damage function. Okay. So, after finding this individual damage function from the pollution MD1, MD2, we are finding the what is the total damage function that the society is suffering from. So, based on these we can find out what is the optimal level of pollution. So, what is the optimal level of pollution? So, simply you can find out this optimal level of pollution is reached by the intersection point of your marginal saving or the marginal cost function minus of, that is also the minus of marginal cost function with the marginal damage function. So, now we are saying that at this point this is the aggregate marginal damage and this is the aggregate marginal saving or marginal cost function minus of marginal cost function. At this point E, the optimal amount of the pollution is reached. Okay. So, now how you are finding this optimal level of pollution? So, at this optimal level of pollutions, the firm must minimize the total costs and total damages. That is what the optimal level of pollution can be defined, right. So, that means if you are saying in this diagram, if you are saying that this is the intersection point of marginal damage function and your marginal saving function, and you are finding this optimal level of pollution, that is X star, and the price for producing this optimal level of pollution is P star. Okay. So, now you can find that this efficient or optimal level of pollution, that is X star, at this point the firm must minimize the total cost and total damages as well. So, what we are saying is that at this point X star, which you are saying this is the optimal level of pollution, the marginal cost function with related to the pollution at the efficient or optimal level of pollution, and marginal damage at this efficient level of pollution must be equivalent to 0, because we are talking about the optimal level of pollution, and at optimal level of pollution obviously the firm will be trying to minimize the total cost and damages, right. So, this is the first order condition, that how to minimize the total cost and damages. We need to take into account the first order derivative of the total cost, that is the marginal cost, and we are also taking into account the first order derivative of the damages, that is the marginal damages. So, we are summing it up and making it 0, right. So, what we are finding that at this optimal level of pollution, that is X star, right. So, this condition is satisfied because this marginal damage cost, right, is equivalent to the marginal minus of marginal cost, that is equivalent to the marginal saving of the pollution, right. And here what we have found, that this P given phi is determined as P star by the intersection point of your marginal damage and marginal saving function, right. And if this P given phi P star is charged per unit of pollution, right, then what you will be finding, that this marginal cost of producing pollution would be equivalent to minus of P star, or which is also marginal equivalent to marginal saving. So, what you are saying, this marginal cost of X star is equivalent to minus of P star, or you can say marginal saving of at this point optimal level of pollution is equivalent to your P star, okay, because we are saying marginal, this is the marginal saving is equivalent to minus of marginal cost, okay. So, therefore, what you are saying, deducing from this discussion, that this P given phi, that is P star, it is defined as the marginal saving from pollution at the particular point. Which particular point? So, this is at the optimal level of pollution, right. So, this optimal level of pollution is X star. But if you are not taking into account this optimal level of pollutions, so that means we are not considering the only point X star, right. We are talking some other points of pollution. Then this P given phi, that is P star, it is not actually the current marginal cost of pollution control, nor the marginal damage for the pollution that we are that is generated, right. Because of this reason, that this at this optimum, if you are not taking into account or beyond the optimal level of pollution, this P given phi is neither the current marginal cost of the products, this pollution control, nor the marginal damage from the pollution itself. Because of this reason, the P given phi is not an emission fee, right. Rather, it is a special marginal savings from pollution at the optimal level of pollution itself, okay. So, we can actually verify that how this is not an emission fee, rather it is a special case of emission fee which is taken into account the marginal savings from pollution at the optimal level of pollution itself, okay. So, for proving this, we can take this marginal benefit and marginal cost concept from the economic activity of the firm itself, right. So, so what you can do is that if you have to find this marginal benefits, we can take this marginal benefits can be interpreted as the demand curve, and this marginal cost, it can be taken as the supply curve. So, this is the standard microeconomics principles. And obviously, when you are talking about the the efficient level of production, we can find this efficient level of production by taking into account the intersection point of these two marginal benefits, that is demand and marginal supply cost, marginal cost curve, that is the supply curve, right. So, we are taking into account this demand and supply factor into consideration for finding the efficient level of production. And we can also find out at that point we can also determine the market price for the pollution itself. And again we have already understood that in case of externality, let us take the negative externality like your emission or pollution, this marginal social cost is obviously much higher than the marginal private cost, right. So, and also this marginal social cost is also not taken into account the other concept like your externalities. Okay. So, in this context the marginal social cost is higher than the marginal private benefit and marginal cost itself, and when we are finding this problem, that is marginal social cost is greater than the marginal cost, or this marginal cost is also taken as the marginal private benefit, okay, because it is the farm will be getting benefits by producing more and more of output and generating more and more of pollution. So, in this case we can take this tax, right, we can consider a tax to be imposed, right, for this externality concern, so that these externalities can be adjusted or internalized. So, what we are saying that this marginal social equivalent to this marginal private cost, it will be equivalent. So, what we are doing that we understood that this marginal social cost is greater than the marginal benefit, right, marginal private benefit. Okay. So, in order to make these two equivalent, what we are saying, this marginal social cost to marginal so what we are doing that we need to add the tax itself, right. So, this tax plus marginal private benefit in order to make this equivalent to the marginal social cost. So, that what you can say that we can compensate the externality. Okay. So, from our previous discussion we know what is the Pigouvian tax itself, and in this case we will be just highlighting that how this Pigouvian tax is a special case of the pollution fee or pollution tax, right. So, what we are saying that we can prove this by taking into account a graphical representation, where in the x axis we are measuring the output and in the y axis we are measuring the price. Okay. So, the marginal private cost, this is the curve, and this marginal net private benefit, it is also there, marginal net private benefit. Okay. And if there is no intervention from any regulator, or there would be no kind of regulation from the government side or any regulating authorities, then obviously the farm will be interested to produce at this equilibrium point. So, what is the equilibrium point? Where the marginal net private benefit, that is the demand curve, is intersecting the marginal private cost, that is the supply curve, right. So, this is the point of intersection. So, without any intervention the farm will be interested to produce at this point E, right. But however, this is not a socially efficient output and social efficient price, right. Why? Because here the marginal private cost is actually less than the marginal social cost, that means externalities is there. So, in order to find the socially efficient quantity, we need to find out what is the social marginal social cost, right. So, what would the marginal social cost? So, that would be the marginal private cost plus the externality. Okay. So, let us say we have taken into account this externalities and this is the marginal social cost. What is marginal social cost? This is the marginal private cost plus externality. Okay. So, when this marginal social cost is intersecting the marginal net private benefit, we are getting this equilibrium, that is E star, right. Now, corresponding to this equilibrium, this Q star is the socially efficient quantity that is produced and the socially efficient market price is P star, right. So, this is how we are finding that Q star is the socially efficient quantity, because we have taken into account the marginal social cost here, right. And this marginal social cost is marginal private cost plus this much of externality that we have taken into account. Okay. So, now we will be just considering what would be the level of this Pigovian tax for controlling the pollution itself, right. So, what is the amount of this Pigovian tax, or what would be the extent of Pigovian tax? So, we know that this Pigovian tax is equal to the marginal external cost, right. And this marginal external cost is decided, it is determined by the difference between marginal social cost and marginal private cost, right, at the point of socially efficient production. So, what is the socially efficient production that we have discussed? It is the Q star in the last graph that we have discussed, okay. And there we are finding what is the marginal external cost. So, marginal external cost is the difference between the marginal social cost and the marginal private cost, right. So, that means this the Pigovian tax, that is equivalent to your marginal external cost, which is determined by the difference marginal social cost minus marginal private cost. This tax is equivalent to the marginal cost, right, at the point of socially efficient production only. So, that means at Q star only this T is defined as the marginal external cost. So, T at Q star, this Pigovian fee is equivalent to the marginal external cost, which is equivalent to the marginal social cost minus the private marginal cost, right. So, that means we can say that this tax, Pigovian tax, is not equal to this marginal external cost if you are taking into account the other quantities or other points. So, except this socially efficient quantity, right. And even though we are saying this tax is introduced, that is P star amount of tax is introduced, right, but still it cannot actually compensate the externalities present at points other than the Q star. Okay. So, therefore, what we are saying that if the firm is producing beyond Q star, that is optimum level of externalities, then there will be some kind of externalities still present, right, which are not going to be taxed if you are following the per unit tax for pollution. Okay. So, because of this following logic that we have already made, this Pigovian fee is not actually an emission fee, rather it is a special kind of pollution tax. Why? Because this Pigovian tax is only applicable when we are taking into account this socially optimal level of output. So, if we are taking into account any other point beyond the socially optimum level of output or socially optimum level of pollution, that is Q star, then this Pigouvian P is not actually going to address these externalities. That means some kind of externality will still be present, although we are imposing this Pigouvian tax, which is equivalent to your marginal external cost, we are saying, right. So, now let us discuss that how this Pigouvian P is imposed when there are multiple sources of polluters, right. So, here the basic rule that we are taking into account in case of this multiple polluters, we are following this marginal cost conditions, right. So, this is the another very common principles we are using in microeconomics. This is marginal cost conditions. So, here in a case of multiple polluters, we are taking into account the marginal saving function of the pollution, right, and we are also taking into account the individual marginal saving function of each individual polluters. So, let us say this MSX is the total marginal saving function of all the polluters. So, this MSX is telling us how much of pollution in total can be emitted by all the polluters, right. And when we are talking about the individual marginal saving function, right, corresponding to this level of output. So, it is telling how much each farm or each polluters they will be contributing the total marginal saving for the pollution. Okay. So, we can show this, we can actually explain this in terms of a graph. So, in the x axis we are taking into account the pollution, okay, and in the y axis we are taking into account the price. So, what we are saying that let us say there are two polluters, polluter farm 1 and its marginal saving function from polluting is can be denoted as MS1x, and there are also another polluting farm and its marginal saving can be denoted as MS2x, right. And we are also finding the marginal damage from the pollution of the two farms. So, this is marginal damage of pollution. So, this is x is your pollution. Okay. So, now what we need to find that we know this individual marginal saving function from farm 1 and this is MS2 is the individual saving function from the pollution for the farm 2, right. So, what we need to find out is the total marginal saving function. Okay. So, how to find out this total marginal saving function? So, now we need to be careful that what kind of good it is, whether this marginal saving function from the pollution, whether it is a private good or a public good. Obviously, it is a private good. Okay. So, since this marginal saving is a private good for both the farms and the farms will be actually taking the benefits of this marginal saving functions, right. So, the total marginal savings it can be found by the horizontal summation of the individual marginal saving curves, right. So, how you will be finding the so this will be your total marginal saving functions, right. And now we need to find out what is the efficient amount of pollution. How to find? Obviously, it is the efficient level of pollution is found by the intersection point of your marginal saving function, which is the summation of all the marginal saving curves and the marginal damage function. So, this is the point. let us say it is A star, and there we are finding this is X star, right. This is the efficient amount of pollution. Okay. And what is the corresponding price level for this pollution? It is P star. And this P star is said to be the pollution fee, or in this case it is the Pigovian fee, because it is determined at the efficient level of pollution, right. And at this P star, firm 1 will be generating, obviously the total pollution to be generated is OX star. So, what is the portion of the pollution that is to be generated by the first firm? It will be found out by this P star when it is crossing the marginal saving function of the first firm. So, this is X1 star. So, the firm 1, first firm will be generating OX1 star, this much of pollution. Likewise, for the firm 2, it will be generating how much? This P star is intersecting the marginal saving function of the second firm at this point, and corresponding to it we are finding this, let us say this point is X2 star, right. So, now the firm 2 will be generating this OX2 star, this point, this amount of emissions. Okay. So, now what we are saying, that each firm they will be operating, right, in such a way that this marginal saving from polluting will be equivalent to the Pigovian fee. What we are saying, this marginal saving is equivalent to your pollution fee, that is Pigovian fee here, and moreover the individual marginal saving functions would be equivalent to each other. So, marginal saving of the first firm will be equivalent to the marginal saving of the second firm, which will be equivalent to the pollution tax itself, right. So, what is the meaning of it? That means the Pigovian fee, right, is taken into account and following the equimarginal principles of pollution control, and that is why at this fee, Pigovian tax or Pigovian fee, this equimarginal principle is followed, where marginal saving function of the first firm is equivalent to the marginal saving function of the second firm, which is equivalent to the Pigovian tax itself. Okay. So, this is how you can follow these books. The first one is Environmental Economics, an introduction by Field and Field, and the second one you can also follow this intermediate Environmental Economics by Charles D. Goldstadt. Okay. And in the next lecture, we will be continuing with the same instruments, this is market based instruments, and we will be discussing the case of the subsidies. The second case is the subsidies. Okay. Thank you very much.